Hey, welcome. This is your LI AI. Today we are going to learn rate limiter system design in about 10 minutes. Interview ready? Now picture a launch. Your product is on the front page. 50,000 requests a second show up, mostly real users, and it looks exactly like DDoS. Candidates shrug, stick Redis INCR on a user key inside the service. So what happens? The edge already burned sockets. Auth already ran. Fixed windows double burst at the boundary. And when Redis blips, nobody said fail open or fail closed. The naive design sounds tidy, right? One counter, one TTL sounds easy. Wrong. The whole interview falls apart. Wrong hop, wrong algorithm, no failure story. Today's real problem is not drawing Redis, it's placing limits before expensive work, picking a bucket you can defend, and owning accuracy under fleet skew. By the end, you should redraw the board cold. Alright, let's lock requirements. Requirements lock before boxes, functional, limit by key, user, IP, API key, tenant. Return allow or deny fast with remaining and retry hints when you can. Support multiple rules, per route ceilings and a global tenant ceiling. Non-functional. Decision latency should be about a millisecond locally. You cannot afford a chatty round trip before every upstream call. Accuracy can be bounded, say plus or minus a few percent under skew, but unfair starvation should not be a surprise. And failure mode is required speech, fail open or fail closed. Below the line, full bot machine learning scoring, billing metering UI, multi cloud policy sync. Park them unless asked. You are designing throttle physics, not the whole abuse platform. If time is tight, drop fancy dashboards first. Placement and algorithm stay. Next, APIs and the expensive path trap. APIs and entities, boring shapes, loud trap, post slash v1 slash check, body, key, cost, route, response, allow or deny, remaining, reset milliseconds. That is the hot path. Keep it tiny, get slash v1 slash quota slash key for ops, put slash v1 slash rules for the control plane. Do not mix admin rights into the hot check path. Entities. Limit rule, template, limit, refill or window, algorithm, scope, bucket state, tokens and last refill or your sliding structure. Decision log, sampled, async for forensics. Never require a log write before you return deny. Trap, counting only inside the app after auth, decode and validation. You already paid the expensive path before you said no. Staff move. Identity aware checks as early as trust allows. Coarse anonymous limits even earlier at the edge. Say that trap before you name Redis. Back of envelope. Numbers that force placement. Peak herd around 50,000 RPS. Decision budget about 1 millisecond before upstream work. Accuracy tolerance may be plus or minus 5% under multi-node skew. Say the bound so you are not pretending perfect global fairness across every pod. Counter storage is tiny. The envelope is not about terabytes. It is about where each millisecond goes and how much unfairness you accept for speed. If your check needs 2 network hops and a JSON round trip, you already blew the budget. Those numbers force layered checks and an atomic bucket update, not a casual INCR in application code after the heavy lifting. Next board, the HLD those constraints demand. High level design, hops forced by cost of work, client hits edge, coarse IP and WAF style limits, cheap and early. Then API gateway, authenticated identity, route rules, tenant ceilings, a limiter service or sidecar talks to Redis with an atomic script. optional local token cache for ultra hot keys. Only then do you enter the app service. Metric sample decisions async so the hot path stays lean. Story coarse then precise. Global keys need a central store. Some paths can shadow local tokens and reconcile. Forced boxes, edge, gateway, bucket pass the rename test. If your diagram is only client, load balancer, service, Redis, you skip the physics of expensive work. Own the hops, then own the algorithm. Deep dive 1, placement, wrong versus correct. Wrong, only limit inside the service, edge sockets and TLS are already burned. Auth and JSON decode already ran. A noisy neighbor takes a whole tenant down because you never had a global ceiling at the gateway. Correct layered placement. Edge for coarse anonymous abuse, gateway for identity and per route policy, service for business quotas that need domain context. Always ask what work is expensive and how early can I deny. Staff note, fail open versus fail closed is not a footnote. Payments might fail closed. Public read APIs might fail open with alarms. Say the product call. Next, the algorithm that makes Redis INCR look incomplete. Deep dive 2, token bucket versus naked INCR. Wrong, Redis INCR with a fixed window TTL. At the window boundary, you can double burst. There is no refill semantics, just a cliff. Clock skew across nodes makes denies feel random and unfair. Correct, token bucket. Tokens refill at rate R. Burst cap by bucket size B. Update atomically with Lua or a single key script so check and decrement cannot race. Sliding log is an alternative when you must defend exact request timestamps. More memory. Say why. Staff line. INCR is a primitive. The policy is the algorithm plus placement plus failure mode. Bound the error under skew and move on. That is the punch. Redis INCR is not enough. If you want to practice this loop live, boards, probes, timed mocks, sign up on YourAlly AI at yourally.live. Written boards for design rate limiter also live on your Ally Academy. Alright, closing checklist. Recap, say it with the architecture. 1. Place limits early, edge, then gateway, then service. 2. Pick an algorithm you can defend. Token bucket with refill and burst. 3. Update atomically. Lua, not hope. 4. Say fail open or fail closed before they ask. Payments and public reads are different product calls. Hold the mini HLD, throttle before expensive work. Redis holds bucket state, the app is last. Redis INCR is a primitive, not your design. Practice the full board on your Ally Academy, design rate limiter, and keep reps on your Ally AI at yourally.live. Your Ally AI interview OS. Don't guess under the clock. Practice.